Okay, this video is going to go over Chapter 24, Nutrition, Objective 2, Part B. We're going to talk about lipids in this video. So, with lipids, the one we're going to be talking about is triglyceride. Remember, there's a bunch of different types of lipids. The specific lipid we're going to talk about in terms of nutrition is the triglyceride, and it is made up of a single glycerol molecule and 3 fatty acid chains. So here's the actual structure. When you put all those carbons and hydrogens, you can see that glycerol backbone right here, and then those 3 fatty acid chains. Lipids, just like carbohydrates, are considered a macronutrient, so you do need them in large quantities. It is an organic molecule, meaning it does contain carbon, and you can see right here all of those little carbons that are in there. It is energy yielding, meaning this is going to be directly used by the body to make ATP. Now, how much of it do you need? You're going to need 20 to 35% of what you eat should be in the form of triglycerides or lipids. So, for example, if you consume 2,000 kilocalories per food a day, then 400 to 700 kilocalories of that should be in the form of fat. So you're looking at about 65 grams a day. So you're going to need to know this relationship here, just like you had to for carbohydrates. For every gram of fat consumed, you're going to produce 9 kilocalories of energy. So that's quite a bit different than carbs. It's actually more than double the amount of energy you're going to get per gram of carbohydrate. So let's look at our meatball marinara sandwich again. Get my little pen out and let's take a look. So we're going to look at our meatball marinara sandwich, and we're going to be looking at the fat column this time. So for the meatball marinara sandwich, if you consume it, you will be eating 15.5 grams of fat just with that one sandwich. So how are you going to calculate the amount of energy that you're going to get from that fat that you just ate? Well, you're going to use this relationship of 9 kilocalories of energy for every gram. You're going to take the grams, which was 15.5 grams, and you're going to multiply it by the 9 kilocalories of energy for a total of 140 kilocalories of energy. So what that means is, of this 435 kilocalories of energy that you're going to get from eating that sandwich, 140 kilocalories are coming directly from the fat section. Just in case you were wondering, because I know we all wonder about butter sometimes, 60 grams of fat is about 2/3 of a stick of butter or 1/4 of a cup of oil. Amazing. So you only need 65 grams of fat a day, and if you eat 2/3 of a stick of butter, that's your daily allowance. You're like, who eats 2/3 of a stick of butter? Have y'all ever been to the fair? They serve fried butter at the fair. Now, I've not actually eaten the fried butter. I hear it's good, but I don't know how big, I don't know how much butter it is. Is it a whole stick of butter that you get? Right there. And then let's not talk about them frying it, right? So just the butter part, not even the fried part. So if you go to the fair and eat fried butter on a stick, you're getting more than you need of your grams per day for fats. Again, I've got nothing against McDonald's. I love McDonald's, but I just wanted to show you something here. So with the McDonald's small, now I will say this is older data. I don't know if the smalls have changed and if they're smaller than they used to be or not. So I can't remember when I pulled this data. But anyway, if you're looking at a McDonald's small French fry, you're looking at 11 grams of fat. Okay, that's not too bad, I suppose. If you're looking at the medium, that's 19 grams of fat. And then if you're looking at the large, that is 25 grams of fat. So that is about 1/3 of the fat that you need for the whole day just by eating the large. That's not including what you got to go with it. So 1/3 of the fat that you need is just from that one thing of French fries. So think about it next time when they say, would you like to upsize that? Be careful, because while it may be cost effective to do that, it may not be dietary effective to do that. If you were looking at those mocha drinks that you get from all these different stores, look at the amount of fat content in those. So again, McDonald's and Dunkin' Donuts look like they're kind of competing with each other there. So again, that's 24 grams of fat for McDonald's, 23 grams for Dunkin' Donuts. I will say, you know, it depends on what drink anymore and what size. I didn't put what size these were. So yeah, if you eat the French fries and drink a mocha drink for McDonald's, right there is 2/3 of the fat that you need for the day. So you do need to know how lipids are digested and absorbed. So here's a little video here if you needed to go back and take a look at that from chapter 23. So you've got your fat globules, these lipids, and remember the function of the bile that is coming from the gallbladder, which is concentrated bile, and the liver. It is producing some bile, but it's not concentrated. It's going to take that, and bile's job is to emulsify the fats. So it's going to take those fat globules and surround them to keep them from coming back together again, forming that big, huge fat globule. And then lipases are going to come in and help break that food down chemically, break those fats down chemically, and you're going to get free fatty acids, monoglycerides. Mono means one. And some bile salts. Then they're going to form these micelles. They're going to go through, this right here is your intestinal lumen, so they're going to pass through that wall of the intestine. They're going to get converted back into triglycerides, and then form chylomicrons, which are going to be secreted out. And look where those chylomicrons with the triglycerides on the inside are going to go. They're going into the lymphatic system. That lacteal is part of the lymphatic system. Remember, I said anytime you see green, you might want to be thinking, okay, bile, yes, but lymphatic system is also represented by the color green when you're looking at images. They will eventually end up back in the circulatory system over around the subclavian vein, right before it gets into the superior vena cava and enters into the right atrium. Now, lipid use in the body. Lipids are an energy source that can produce ATP. Remember, 1 gram of lipids is going to equal 9 kilocalories of energy, more than twice that of carbohydrates. Any excess lipids, triglycerides that are not used, are going to be stored in adipose tissue or the liver. Yes, the liver can store fat as well. That's called fatty liver disease, right? Fatty acid liver disease. Adipose tissue is located under the skin. It's kind of like, where is adipose tissue not going to be found? It's found everywhere, as well as surrounds and pads organs. So again, you do want some, you don't want excess. Lipids build molecules, so they're important. We do need them. They build molecules such as your steroid molecules, cholesterol, vitamin D, testosterone, and estrogen. For fuel storage, look at the supply here. My goodness, it is unlimited fat storage here. Take a look at that. In comparison to how many kilocalories of energy we were storing in the form of glycogen, look how much energy we're storing in the form of fat. Now, sure, you're getting over twice the amount, but oh my goodness, even the grams. Okay, 15,000 grams of fuel storage. This is probably just for a normal body, not for someone who has excess fat storage. So I wanted to show you kind of what a fat cell, an adipocyte, looks like. A lot of times we just think it's just this sphere that contains a bunch of triglycerides, but there is also a lot of metabolic activity that is going on inside of that adipocyte. So it does have activity. You don't have to necessarily know what it is, but it is an active cell. So fat is considered long-term energy storage as opposed to carbohydrates, which are your short-term energy storage in the form of glycogen. Fat is stored in the form of triglycerides in cells known as adipocytes. And if you remember from histology, right there is a histology slide showing adipose tissue. And that concludes our lipids.